Incoming solar radiation is not evenly distributed on the Earth. At the equator, due to higher levels of solar radiation, the air warms up, its density decreases, and it rises. On reaching the upper atmosphere, it cools down, and the density and pressure of the air increase. This high-pressure air mass flows towards the poles. The reason for this is that, at the poles, the density of the cold surface air increases. This creates high pressure at the surface and low pressure in the higher, more rare atmospheric layers. When the high-pressure air reaches the poles, it sinks to the surface of the Earth and moves towards the lower-pressure equatorial areas. This ideal atmospheric circulation pattern would be the case if the Earth were stationary. The Earth rotates, however, so this ideal atmospheric circulation pattern is not what actually happens. As a result of the Coriolis force, there are 3 circulation cells in the troposphere in each hemisphere. Along the equator, we find the Hadley cell, around the poles, the polar cell, and in the middle, between 30 degrees and 60 degrees north and south latitudes, the Ferrel cell. Due to the rotation of the Earth, the air does not flow in a north-south direction. It is rather deflected westwards. This deflection is due to the Coriolis force. That is, it is due to the inertia of the air mass caused by the Earth's rotation. The tropical atmospheric circulation, known as the Hadley cell or the trade wind system, occurs along the equator. Here the air warms up, rises, and then cools down at higher altitudes, which results in precipitation. This creates good conditions for the formation of tropical rainforests. Then, the high-pressure air flows towards the Tropic of Cancer and the Tropic of Capricorn. Around 25 degrees north and south latitudes, the large air mass sinks and returns to the low-pressure equatorial areas. The downward branch of the Hadley cell transports no moisture, which causes good conditions for deserts to form. The circulation of the Hadley cell is permanent. The polar cell occurs around the poles, where the polar high-pressure cold air flows towards the equator. The cold air warms up, rises, and cools down, resulting in a new high-pressure atmospheric layer. This high-pressure air flows back to the poles because there, the pressure of the high atmospheric layer is lower. The Ferrel cell occurs between the Hadley and the polar cells. Since air flows both towards the poles and the equator, the Ferrel cell is affected by the downward branch of the cell. The winds prevailing in the Ferrel cell, known as the westerlies, blow from the west and bring rainfall. Jet streams play an important role in the formation of the Ferrel cell. Jet streams are fast-flowing air currents that flow from the west and originate high up in the atmosphere at the border of the Ferrel cell. They play a significant role in the creation of cyclones and anticyclones.